Security, a double-edged sword. While client-server systems offer improved security through centralized controls like firewalls and encryption, this can also be a disadvantage. These systems function like fortified castles, strong defenses, but if breached, the entire kingdom falls. The 2021 Colonial Pipeline ransomware attack demonstrates this vulnerability, where a single compromised password led to widespread disruption. Companies now implement multi-factor authentication and zero-trust approaches to mitigate these risks. However, when security responsibility is concentrated, poor configuration or outdated protocols can create vulnerabilities affecting all users simultaneously. This centralized nature makes security both a major strength and potential weakness of client-server architecture. Scalability, growing without growing pains. Scalability refers to a system's ability to handle growing workloads or expand to accommodate growth. Client-server systems excel in this area, as demonstrated by major platforms like Facebook, handling billions of users, and Amazon managing peak events like Prime Day. These systems can grow in two primary ways: vertically by adding more power to existing servers, or horizontally by adding more servers to the network. Cloud elasticity through platforms like AWS and Azure allows businesses to automatically scale resources based on demand. This capability enables startups to rapidly increase capacity when experiencing unexpected growth rather than suffering downtime. However, poor scalability planning can lead to excessive costs if resources are over-provisioned. The need for backup systems. Backup systems are essential in situations where service interruption could have serious consequences. In healthcare, patient management systems require backups to ensure continuous access to critical medical information. Financial institutions implement redundant systems to maintain transaction processing capabilities. Google Cloud exemplifies this approach with automated failover systems that redirect traffic to secondary servers when primary servers fail. Similarly, banks implement geographically distributed data centers to ensure operation continuity even if one location experiences an outage. These examples highlight how proper backup systems can prevent catastrophic disruptions in mission-critical services like emergency communications, air traffic control, and e-commerce platforms where downtime directly impacts revenue and customer trust. Back-end processors, the brains of the operation. Back-end processors are the silent workhorses of client-server systems, components that handle data processing, business logic, and system operations on the server side. In financial technology, these processors verify transactions, manage accounts, and maintain security protocols. They're not limited to numerical operations. They're increasingly incorporating machine learning capabilities. Amazon's product recommendation system exemplifies this, analyzing browsing and purchase history in real time to suggest relevant products. Social media platforms use back-end processors to filter and prioritize the content users see. Healthcare systems employ them to process patient data and insurance claims. These powerful systems work continuously behind the scenes, performing the complex operations that make modern digital services possible while remaining largely invisible to end users. Front-end processors, where users and tech collide. Front-end processors focus on creating human-friendly interfaces and managing how users interact with the system. Modern frameworks like React.js and Angular transform what could be clunky interfaces into smooth, app-like experiences. Consider Spotify's web player. Though running in your browser, it functions nearly identically to a native application thanks to single-page application technology. Banking apps use front-end processors to create responsive interfaces that adapt to different device sizes while maintaining security. E-commerce sites rely on front-end processing to deliver dynamic shopping experiences with features like live search results and interactive product displays. These processors serve as the crucial bridge between complex back-end operations and intuitive user experiences, determining how customers perceive and engage with digital services. Development frameworks, the toolbox. Development frameworks provide standardized environments for building robust applications. .NET offers enterprise-level capabilities with cross-language compatibility and memory management through common language runtime. Ruby on Rails emphasizes convention over configuration, enabling rapid development used by platforms like GitHub and Basecamp. Python frameworks include Django for full-stack content management applications and Flask for lightweight APIs. These frameworks offer standardized structure, built-in security features, and efficient development workflows that reduce repetitive coding tasks. By providing libraries and tools for common tasks, frameworks allow developers to focus on creating unique features rather than rebuilding standard components. This toolbox approach accelerates development while maintaining consistency and reliability across complex client-server applications. Collaboration tools, more than just file sharing. Collaboration tools have transformed how we work together on documents and files. Google Docs enables real-time editing with multiple users simultaneously, with the added security of version history tracking. Its comment and suggestion functionality proves invaluable for feedback, though it occasionally glitches with spotty internet connections. Conflicts can arise when multiple people edit the same section simultaneously, leading to potential confusion or lost changes. Beyond Google Docs, Microsoft Teams became essential during the pandemic for document collaboration and communication. Dropbox has proven reliable with its version history feature when content is accidentally deleted. OneDrive's integration with Office applications streamlines workflow across platforms. While these tools offer significant advantages over traditional file sharing, they still have limitations related to connectivity and collaboration conflicts that remind us no system is perfect. Scripting, the glue, holding it all together. A major disadvantage of client-server systems is the potential single point of failure. If the main server goes down, the entire system can become unstable or completely inaccessible. When a banking server fails, customers cannot access their accounts until the issue is resolved. Similarly, an email server crash can block all organizational communication. These failures significantly disrupt business operations, causing financial losses and damaging customer trust. Web server crashes can make entire websites unavailable, while database server failures affect all dependent applications. This vulnerability highlights why scripting plays such a crucial role. It provides the flexibility and functionality that helps connect components, implement failover mechanisms, and create more resilient systems that can recover quickly from potential failures. Client-side scripting, JavaScript and jQuery. Client-side scripting languages like JavaScript and jQuery execute in the user's browser to create dynamic web experiences. JavaScript can manipulate the document object model to change page content on the fly, handle user events like clicks and keystrokes, fetch data asynchronously, and validate forms before submission. jQuery simplifies many common JavaScript tasks with a more concise syntax. For instance, hiding an element requires just one line in jQuery versus multiple lines in vanilla JavaScript. These technologies enable interactive web forms with real-time validation, dynamic content loading without page refreshes, responsive interfaces that adapt to user actions, and rich web applications with desktop-like functionality. From showing personalized greetings to implementing infinite scrolling on social media, client-side scripting transforms static web pages into engaging, interactive experiences that respond immediately to user input. Development frameworks. Development frameworks provide standardized environments for building robust applications. .NET offers a comprehensive enterprise-level solution with cross-language compatibility and memory management through common language runtime. Ruby on Rails, used by platforms like GitHub and Basecamp, emphasizes convention over configuration to streamline development. Python offers frameworks for different purposes. Django provides a full-stack solution for content management systems, while Flask offers a lightweight alternative for APIs and smaller applications. These frameworks include libraries and tools that handle common tasks, allowing developers to focus on unique features. By providing standardized structure, frameworks reduce repetitive coding tasks and enable more efficient development workflows. They serve as the foundation upon which complex client-server applications are built, ensuring consistency and reliability across the development process. Server-side scripting, PHP. PHP handles crucial behind-the-scenes functionality in client-server systems by processing logic on the server before sending results to the client. It connects to databases, manages sessions, authenticates users, and generates dynamic content based on user inputs. Server-side scripting offers significant advantages by securing sensitive operations away from the client, centralizing processing for consistent execution, and handling resource-intensive tasks that would be impractical on client devices. PHP remains popular for server-side development due to its ease of use and extensive capabilities for database integration. By controlling data access and validation on the server, PHP and similar server-side languages help maintain security and data integrity while delivering personalized content to users based on their specific needs and permissions.